I'm Anil Kumar and I have compiled a set of videos for grade 11 students so that they can review what they have learned in grade 10. So just in few videos we'll cover everything what they are supposed to know to move forward in grade 11 with quadratic functions. So in this particular video we'll talk about quadratic functions in the form of y equals to a x minus t whole square plus y, and these are the properties which we are going to look into. They are parent function is y equals to x square, first difference, second difference, shape of the curve, opening, up or down, domain, range, vertex, axis of symmetry, zeros, and forms of equations. So there's a lot to cover in this video, so it's going to be a bit lengthy, but I think worthwhile for you to spend some time so that it'll be easy for you as we move forward. Okay, so let's look into the parent function y equals to x square. The key points which we always consider when we say parent function y equals to x square are the points for x and y, where x values are normally taken as -2, -1, 0, 1, and 2. And the corresponding y values are square of these numbers. Square of these numbers are 4, square of 1 is 1, 0, 0, 1, and 4. So that is the set of x and y values. If we plot them on a graph, we get a parabola as shown here, right? Vertex at origin, axis of symmetry is right there. Equation is x equals to 0. Now since the parabola opens upwards, it has a minimum at the vertex, right? So that is how every parabola will look like. It could be inverted, transformed, stretched, or compressed, but the shape remains as it is. Now let's look into some properties of this function. One of the first property is first difference. What do we mean by first difference? First difference is actually the difference in their consecutive values. So if we calculate from the given set of values the difference in their consecutive values, then what do we get? 1 minus 4 is minus 3. 0 minus 1 is minus 1. 1 minus 0 is 1. And 4 minus 1 is 3. So that is the first difference. At times, we may write this first difference as delta 1. As you note here, the first difference is not constant. That means the function is not linear. It could be something but not linear. Now let's try to find what is the second difference. Now second difference, which I mentioned here, so we have already done these points. Second difference is difference of the first difference consecutive terms, right? So we do again the same process, that is minus 1 minus of minus 3. So when you do that, you get 2. Do you see that? And then 1 minus minus 1. You again get 2. 3 minus 1, you know, is 2. The second difference here is constant. If the second difference is constant, we know it represents a polynomial of degree 2, which is a parabola when you sketch it, and it's called the quadratic equation. So in every quadratic equation, the second difference will be constant, and somehow it will be related with the leading coefficient, and we will see its relation soon. So we know one thing now, that for a quadratic equation, first difference is not constant, but the second difference is, and it is related to the value a. We started with x square. Here a is 1. What did we get? 2 times 1. So the relation actually is 2 times second difference, right? So a is always equals to, the leading coefficient a is always twice the second difference. So we did the first difference for y equals to x square, which had a leading coefficient of 1, but the second difference of 2, twice 1. So you can experiment with different forms of equation and check whether the second difference is really 2 times the a value or not, right? As you can see, the sign of difference also tells you in which direction the parabola is going to open, right? Now let's get into the shape and opening of parabola. Parabola, as we are always saying, is something like shown here. Every quadratic equation, if you sketch, will be in this shape, right? And it could open up or down. It really depends on the leading coefficient. Opening is dependent on leading coefficient. So if leading coefficient A is positive, right, that is greater than 0, in that case it opens up. And if A is less than 0, then it opens down. Right? Domain. Domain of quadratic function is all real numbers. There is no restriction. It's a smooth curve which moves from minus infinity to plus infinity. Range, however, is limited to one side. It could have absolute maximum or minimum. So the range is restricted. Say y belongs to real numbers where y could be greater than equal to some value in case it is a minimum like that. So for our parabola, which we are considering x square, it is greater than equal to 0. Do you see that? But if we transform it, this point will change. But the main thing to remember is that domain is not restricted, but range is restricted. Vertex. Vertex actually is the turning point. If you are given an equation in vertex form, you can read the vertex directly. For y equals to x square, vertex is 0, 0, right? So it is 0, 0 for the parent function x square. But if you have a transform function like this, then the vertex is dc, if we have it in vertex form. Axis of symmetry. Axis of symmetry is the line which goes through the vertex. And you'll find that every point on the parabola has a reflected image on the other side, like this. So it is symmetric about axis of symmetry. Equation of axis of symmetry for x square is x equals to 0, but if we consider equation the form of vertex, then it is x equals to d, right? So in that place, when it is a transform function, axis of symmetry will be x equals to d. Now let's talk about zeros of parabola. Zeros, or I should write x-intercepts. I think I should write x-intercepts now, and then we'll also discuss about difference between x-intercepts and zeros. Now normally when you see a parabola y equals to x square, how many x-intercepts do you see? You see only one. So there's one x-intercept. But if I move it a bit up, then what happens? Then there won't be any x-intercept, right? So 0. But if I push it down, then it could have two x-intercepts. So a parabola can have either 0, 1 or 2 x-intercepts. Now how do you figure out how many x-intercepts a parabola will have? So that b square minus 4ac is what you need to calculate. If b square minus 4ac is positive, then we have 2 x-intercepts. If it is 0, then we have 1 x-intercept, and if it is negative, then we do not have any x-intercept. Let me write the word none, right? So these are the x-intercepts we're talking about. And we need to test b square minus 4ac to figure out how many x-intercepts the function will have, provided we are given equation, right? From the graph you can always see. Well, from equations like this, we can also figure out how many x-intercepts it will have. And for that, what you need to do is to check the values of a and c. If both of them have same sign, well, let's consider this. C is 0. If c is 0, then it will have 1 x-intercept. But if both have same sign and c is not equal to 0, then it is not going to have any x-intercept. But if it has different sign, then it will have 2 x-intercepts. We'll explore this property in the coming videos. And then forms of equations. We have discussed one, which is called the vertex form. The other is one is the standard form, which is ax squared plus bx plus c. And the last is factored form, a times x minus x1 times x minus x2. So these are the different forms in which you can write your quadratic function. And third, of course, I've written right there on the top, which is a times x minus t whole square plus c. These three different forms of equations are used in many different ways to figure out different properties and characteristics of quadratic functions, which we are going to explore in the coming videos. I find and I think that this set of videos which you are going through will quickly review what you need to know and take you forward. All the best. Thank you.